All right, John, we are live.
All right. Thanks a lot, Michael. Good afternoon, everyone. My name is John Fernandez, and I'm a thermal engineer in Facebook's hardware engineering team. And today I'm here to provide a very quick update of the ACS door heat exchanger subproject. So for those who are not aware, the ACS door heat exchanger subproject or workstream has the following defined activities. One is design specific to an open rack only, looking at the data center environmental conditions and associated parameters, defining parameters of interest with regards to how to define performance of a door heat exchanger and also associated specs or test conditions that could be used to evaluate the same, and the definition of different solutions or how a door heat exchanger solution could be employed in different ways. So a lot of this, what's been summarized over here, has been contributed as a document for IC review and been categorized into the following sections that are outlined in the bottom of the slide. So to start off with different solutions, we have three over here that have been outlined. The two on the left-hand side represent the use of a door heat exchanger in an air-cooled facility that also has facility-side coolant capability, supply or facility water systems. And on the right-hand side, we have what's known as an air-assisted solution, which is in a purely air-cooled facility, but the ability to drive a closed loop with the door heat exchanger to be able to push the cooling limits of said air-cooled facility. And Cam will be touching on that in the next presentation. So with regards to the different sections that form the specification document that was previously referred to, we have the physical, we have the dimensional requirements of the OR V2 and V3 rack frames, as well as a recommended depth for the door heat exchanger along with an adapter frame. Now, this is a recommended number, and the most stringent requirement is the ability to hinge open the door heat exchanger when adjacent racks, either abreast or on the other side of an aisle, to be able to open it by at least 90 degrees. To follow on the physical requirements, we do have a weight, preferred weight and a maximum weight recommendation for the door heat exchanger assembly or solution. And the the rack to rack spacing in terms of an aisle is also specified as a minimum of 1200 millimeters. This is feedback as a part of harmonization to enable European tile spacing or size. So continuing on the physical side, we do have coolant, electrical, and communication interfaces outlined in the documentation as well. Once again, calling out the harmonization efforts with regards to ensuring that AB power supply redundancy is put in place as would be potentially be the case on the rack side with the IT gear. And to go along with that, a recommendation from the community in general, has been that the door heat exchange is recommended to be a part of the rack that it supports, both from an electrical and communication standpoint. From an environmental standpoint, we divide this into airside and waterside conditions to be able to scan across the three different solutions that have been outlined in a previous slide. From the air side, we follow the OCP ready guidelines, which has the requirement to meet the Class A1 allowable environmental specification as outlined by ASHRAE TC 9.9. From the water side, once again, going back to harmonization, we mirror the facility side pressurization reference numbers. In this case, with regards to a row level CDU, of course, with the facility level CDU, this would provide a much higher number. We also support different types of coolants depending on what the end user's preference might be. We have water quality requirements as well as filtration requirements. Once again, going back to the different solutions, this would depend on what type of implementation you're looking at. Moving on to performance and metrology, as stated at the start of the presentation, A good starting point was defining the different parameters of interest, and then based on that, figuring out a way to verify the cooling capacity. In this case, the test conditions were based on an IEC standard. If you have an active door heat exchanger, there's a minimum rotor redundancy that's a must. And with regards to the impact, not only to the rack and also the facility side, there are certain requirements depending on whether we're talking about a passive or an active door heat exchanger variant. Moving on to monitoring and control. Now, obviously, you want the door heat exchanger solution to function as required. And as such, implementing sensors, alarms, and controls is one way of ensuring the same. And to do so, the specification has outlined both recommended and required sensors, alarms, and control types, depending on, once again, whether you're talking about the passive or the active variant. Mike Thompson has been very crucial to driving this effort, especially the redfish definitions, which are being defined with the DMTF and the PICMIC groups for application in the door heat exchanger profile or schema. And here's an example of a temperature sensor implementation as part of the redfish definitions. I highly encourage everyone to attend both Mike Thompson and John Liang's sessions at the end of the day, which will be touching on redfish, both from like a more simplistic standpoint, as well as redfish specifically more for cooling applications. Moving on to reliability and quality, this is something that we really got a lot of feedback on from our harmonization efforts, especially from the facility side people. The first is with regards to ensuring that the door heat exchanger solution has some requisite quality in its design. And from that perspective, we look into pressure or leak testing. Once again, over here, we divide this into required or recommended checks, with the checks on the manufacturer side more along the lines of ensuring that the entire assembly is leak proof prior to shipping to either an integrator or an end user. Another aspect that's been brought up quite frequently as part of the discussion with implementing a door heat exchanger has been in-rack airflow sealing. And from this perspective, the documentation does outline once again, an IEC standard, and this is something that integrators can use as a reference to ensure that the way they are mounting or integrating the door heat exchange solution to an IT rack can ensure that both bypass and recirculation and related parameters can be minimized as much as possible. Very quickly, a lot of the material related to the door heat exchanger subgroup can be found on the wiki, whether it is the latest draft of the documentation, as well as Mike's work on the draft redfish definitions and the door heat exchanger mockup. So please check out both the groups and the wiki for additional information. Thank you.
All right, thank you, John. Gave us a couple of minutes to spare here. Sure, Cam will appreciate that. Folks, if you have any questions at all for John or about the work the door heat exchanger sub-project is doing, please track him down. He'll be online a bit more this week. You can find him in the chat, chase after him, learn more about the group and get involved.
Yeah, please, yes, reach out to me offline. I'd be happy to answer any questions that the community may have. Thanks.
All right, Cam, I'm gonna send you a prompt here to share your camera and start up your slides.
All righty.
And folks, just a reminder, this live stream does not change.